This is your quiz review. We're doing 2 quizzes for Unit 10 since it is such a long unit. A little bit of everything on this one. So geometric series, we're going to say converges or diverges and why. If it converges, we can find the sum. Geometric is really the only one that we actually find an answer for. So we have a formula for it. So for this one, our first term is 4. R is negative 1/3. This is going to converge because your absolute value of R is 1/3, which is smaller than 1. And so we can actually find the sum. It's A over 1 minus R. That would be minus negative 1/3, so plus 1/3. I do want you to simplify these because if it was multiple choice, the choices aren't going to look like this. So simplifying it is a good skill. All right, this would be 3/3 plus 1/3, so 4/3. And we're going to multiply by the reciprocal. The 4's cancel, and so we just get 3. For this one, it's set up in our nice format. I don't need to actually look at each individual term. I can just see that A is 5 and R is 7/3. And that diverges because our absolute value of R is 7/3, which is greater than or equal to 1. So the P series is the opposite of this, but remember the equal to always goes with diverges. All right, nth term test. So we're going to do limit as n goes to infinity for this. And so I'm going to use my powers. They are the same, so I'm going to use the coefficients, 2 over 1, which is 2, and so diverges. If it comes out to anything other than 0, it's diverges. So we're going to do the exact same thing for this one. So this is a polynomial. When you have n to a power, like n to the first, n to the second, n to the third, that's a polynomial. This is exponential. An exponential grows faster than a polynomial. So the denominator is going to be growing much, much, much faster and bigger than the numerator. And so this is going to go to 0, so no conclusion. So the nth term test is only for diverging series. So you can show that it diverges. If you get 0, then you would need a different test. So no conclusion. You would need to do something else. All right, so P series, for this one, P is 1/5. And again, P series is opposite of geometric. So diverges because P equals 1/5, which is less than or equal to 1. So again, the opposite of geometric, but the equal to goes with diverges. For this one, P is 8, so converges because P equals 8, which is greater than 1. All right, integral test. We're going to do limit as b goes to infinity, integral from 1 to b, and then I'm going to recopy this with x's in there, so e to the negative 1/2 x dx. It would be a u substitution where u would equal this negative 1/2 x. I'm not going to write out all the steps though. I just know my adjustment number is going to be a negative 2. I just need a negative 2 in there to cancel out the negative 1/2. And e is its own derivative, and so it's its own antiderivative. So it looks like I didn't really do anything, but I did do an antiderivative. It's just that e is itself. So then we're going to do upper minus lower. So plugging in b, it's going to just be this except plugging b in, but I'm going to write it as e to the 1/2 b in the denominator because it's a negative exponent. And then same thing with this one. If you plug in 1, that would just be a half. And then your last step is to evaluate the limit. As b goes to infinity, this is going to get larger and larger and larger in the denominator. So this first portion goes to 0. These negatives cancel, so it's 2 over e to the 1/2. And since we got an answer that's not infinity, like we got a numeric result, this converges. So if you got infinity, you would say diverges. But again, the series does not converge to this number. Series would converge to something larger than this. We don't know what it is, though. Again, geometric is the only one we really ever get an answer for. All right, alternating series. So this alternates. We have the negative 1 to the n in both of them, or you might have negative 1 to the n plus 1. We're going to do limit as n goes to infinity of what the rest of it is. Numerator power is 1, denominator is 2. Numerator is smaller than the denominator, so that goes to 0. And then you plug in n plus 1 and you're showing that that is smaller than the actual series. And that will be true. This denominator, you can try and plug in 1. Let's go ahead and do that. If you plug in 1, you would get 2 over, let's see, would that be 4 plus 1, 2/5. And if you plug in 1 over here, you would get 1/2. So what would that be? 4/10 is smaller than 5/10. So if you're interested, you can do that, but you're showing that the terms are getting smaller is what that is. So converges. So same thing for this one. We're going to do limit as n goes to infinity of everything except for the alternating part. Now, these are the same power, so we're going to use the coefficients, which are 1. Now, that did not come out to 0. So our, it looks like an ln that I put there. Sorry, that's a 1. So our alternating series test didn't work, but what we just did is an nth term test. So diverges by the nth term test. I have this all nice and separated for us. Like I did a section on geometric, a section on integral test, a section on alternating series. But if you wanted to say like by what test, you can of course do that. I sort of separated it for you for this quiz. Obviously on your test in the AP exam, everything's going to be all mixed up. So. All right, and then this one we're going to do a limit comparison test. So we're going to compare this series to another series that will be easier for us to talk about. And basically you just get rid of anything extra. So this diverges. So you can say 2 things for this. You can say diverges because harmonic series. Or you can say diverges because p equals 1, which is less than or equal to 1. But the harmonic series shows up a lot. And so this covers it if you want to do that. So we did a comparison. We showed the one that we compared to diverges. And then we're going to do limit as n goes to infinity of the series we were talking about over the one we compared it to. So this is going to be 1 over n plus 2, and then we're going to multiply by the reciprocal of this. So numerator is power of 1, denominator is power of 1. Again, your coefficients are 1, so it comes out to 1. That's a finite number. And so since the series we compared to diverges, that means the original series diverges too. So what we're saying is because the one we compared to diverges, the original one diverges too.